To properly work with functions and their inverses, you're going to need to understand an operator called the composition or compositions of functions. And it's unlike any operator that we've ever used before. Consider these two functions. F of x, which is x plus 4 in this case, and g of x, which is 5x minus 2. F of g, or f composed with g, or the composition of f and g, they all mean the same thing, is really taking the function g of x and applying the function f to that. So it's f of g of x. We're going to take f of x, and instead of x, we're going to put in g of x. Basically, we're going to apply f to the function g, and then simplify. Now, in this case, if we simplify, we get 5x plus 2. So, the composition of f and g is equal to 5x plus 2. Now this is going to be one of those operators where order counts. F of g of x was 5x plus 2. Let's see what g of f is, or the composition of g and f.
Now what am I going to do?
Well, to take g of f of x, I'm going to start with the function g, and in place of x, I'm going to put, using parentheses, the f of x function. See where the x would have been? I'm going to stick in f of x, which is x plus 4. Now I have to simplify. I guess I'll distribute that 5, and then add the 20 and the negative 2, and I get a completely different answer. 5x plus 18. So order does count in composing functions.
I want details, and I want them right now.
What if you wanted the composition at a specific value? For instance, what is f of g of 4?
I know you are, but what am I?
That's called the composition of f and g of 4, or at 4. Well, we'll take g of 4 and then apply f to it. So here's the f function, and instead of x, I'm going to place in g of 4. Notice I took the g function and put in 4 instead of x. Now if I simplify everything, I'm going to get 18 there, and adding 4. So the composition of f and g at 4, or of 4, is 20.
Fascinating.
Okay, practice makes perfect, so
Thank you, sir. May I have another?
let's try another. Let's let this be f of x, this be g of x, and we'll even have an h of x. Okay? We have 3 different functions here. What would f of g be? Well, that says take the function f, and instead of x in every case, place whatever the g of x function is. See what I did? Now I have to simplify. Now note I have to square negative 2x, so I have 2 negatives in that case, don't I? So I get 4x squared, and negative 6 times negative 2x is plus 12x, and then a plus 2. And that's the composition of f and g in this case.
I want details, and I want them right now.
Okay, once again, let's do the same thing at a specific value.
Well, Poindexter, what do we do now?
Well, that's going to be f of g at 3. Now, g of 3 is the function g with 3 put in, minus 2 times 3. So g of 3 is what? Minus 6. So we're going to take that value and put it in to the f function instead of x. So instead of x, I put minus 6 in every case. And then I simply simplify. And that's going to give me 74. Okay?
Excellent.
Okay, let's mix things up just a little bit here. What about h of f? Now look at your functions. I just made them up, if you would. H means take the square root of something. So we're going to take the square root of the function f. And that's all you can do.
You are correct, sir.
So that's your answer.
Do that again.
How about g of f? We're going to do g to the function f. In other words, I'm going to multiply -2, that's the g function, by what the f function does. Now I can simplify.
Is that your final answer?
I could leave that in that form, but I could also distribute the -2. And that's what g of f is. It's not so hard, is it? It's kind of a weird operator, though, isn't it?
Yoink.
One more.
Ay, caramba.
F of h. So we're going to do f to the function h. And remember, the h is going to go in place of every x. Now we can simplify here. The square root of x squared.
The important thing is, this is your final answer.
We're going to have to simplify that. And I think that's it. Okay.
We can't do it. If we keep this speed, we'll blow up.
Okay, well let's slow down and go try your homework.